Hello and welcome to section 8.1, which is on the Pythagorean theorem and its converse. Pythagorean theorem states that if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So we should have heard this many times over the last couple of years in your math classes. A squared plus b squared equals c squared. The a and the b, remember, are your legs. They make the right angle. The C is never connected to the right angle. It is across from it, and that is always your hypotenuse. The hypotenuse is always the longest side of a right triangle. And remember that this only works for a right triangle. Pythagorean triple, a set of three non-zero numbers for which the Pythagorean theorem works. So if a squared plus b squared equals c squared works, then it's a Pythagorean triple. My first example here, if the hypotenuse of a right triangle has a length of 12, one leg has 6 for its length, what is the length of the other leg? I can just plug it into the Pythagorean theorem. And it doesn't matter if you call this leg A or B, it's going to work out the same no matter where you put it, as long as it's the A or the B. And remember, the hypotenuse is always your C. So 36 plus b squared equals 144, minus 236, so b squared equals 108. And then remember, I'm not trying to find b squared, I'm trying to find b, so I have to square root both sides. And 101 breaks down to square root 36, square root 3, and the square root of 36 is 6. So 6 square root 3 would be your b in this case. Doesn't work out very nice. It is not considered a Pythagorean triple because a, b, and c have to be whole numbers for it to be called a Pythagorean triple. Doesn't mean, it's just because of that square root 3, it doesn't come out evenly. It's kind of a weird one. So theorem 8.2, converse of the Pythagorean theorem. Converse means opposite, so it's said in the opposite way. The Pythagorean theorem said if you have a right triangle. This one starts with if your sum of your squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. The Pythagorean theorem itself starts with a right triangle, blah, blah, blah. This is backwards. If this works, then it's a right triangle. For example, a triangle has side lengths of 16, 48, and 50. Is it a right triangle? You're just going to plug it in and see. Does it work? Is 16 squared plus 48 squared equal to 50 squared? 16 squared is 256. 48 squared is 2304. And 50 squared is 2500. So if you add these two together over here, you get 2560. So 2560 does not equal 2500. So your answer is no, that is not a right triangle. Does not mean it's not a triangle, it just means it's not a right triangle. Theorem 8.3, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. So when you do your a squared plus b squared equals c squared, if your c squared is bigger than your a squared plus your b squared, it's obtuse triangle. Theorem 8.4 deals with an acute triangle. If the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. So if your a squared plus b squared is greater than your c squared, it's an acute triangle. Is a triangle with side lengths of 7, 8, and 9 acute, obtuse, or right? For my last example here, and I'm just going to go ahead and plug it into the Pythagorean theorem. Unless they tell you differently, the numbers they give you are always in the order of ABC. So 7 squared plus 8 squared equals 9 squared. 7 squared is 49, 8 squared is 64, and 9 squared is 81. So what you're looking at is how does 113 and 81, how do they compare to each other. Well, 113 is greater than 81. Therefore, that triangle is an acute triangle. That's this theorem right here. It says if that third side squared is smaller than the other two added together squared, that has to be an acute triangle. So Pythagorean theorem. Bring that knowledge with you, and we'll talk about it more the next time I see you. Have a good night.